Hey guys, Monkhaus here. Today we're going to finish our KNN classifier, and by doing that we're going to determine the best value of k without overfitting for the test data. In the last video we spoke about how only having training data and test data leads to creating a classifier which is overfitted for that specific test data, and what we're going to try to do today is basically to just avoid that error and that mistake. We're going to start now by firstly importing something called cross-val score, and that's in the model selection module. So we're going to come over here and we're going to import put caps on, cross-val score, and on top of that we're also going to import matplotlib. So we're going to say from matplotlib, because we're going to do some plotting, we're going to get matplotlib.pyplot as PLT. So we're going to be making a few changes from the previous video. And the first thing we're going to do is we're going to come down here and I'm going to delete all of this, and then we're going to create a list called k values, and we're just going to use this list comprehension method just because it's nice and neat, and we're going to say I for I in range, and it's the same before, so we're just going to say 152, and all this is going to do is going to create a list for us with values ranging from 1 to 49, including those both endpoints, but it's only going to be odd numbers. So again, if you don't know about why we're doing that, then go back to the previous video, but we just want odd numbers essentially. And because of that, we're also going to change this, and we're going to say k values. So we're also going to change this for loop a little bit. Firstly, we're going to be removing these two middle lines entirely, and we're also going to be changing the bottom line a little bit, and what we're going to do is we're just going to get rid of all of this. So in here we're just going to put the following, so just stay with me for a moment because CV underscore scores doesn't actually exist yet, but we're going to produce that in just a moment. So if you just go one above that, we're now going to create this CV scores, and that's going to now be equal to this cross-val score that we've just imported. And inside here we're going to put our KNN object, and it's going to be our X train data and our Y train data. And then another parameter that we need to include is the CV, and that stands for cross validation, and it's basically the number of folds. If you do none, by default you'll get 5, so that's what we're going to do, but just to not confuse anyone, we're going to put 5. And what this is going to do for us, essentially, it's going to split our train data into 5 folds, and then basically our classifier is going to try and find the best value of k on those folds, and then when we're finally happy with it, then that's when you would actually go ahead and implement the program on your test data. We also need to define our scoring, and that's going to be accuracy, because no capital letters, because that's what makes sense for a classifier. We're trying to see how accurate it is, so that's going to be our scoring. So we want to find the optimal value of k, and we've got this list of accuracies which is kx scores, and we're basically going to try and just find the highest accuracy, and then once we have the position of that highest accuracy, then we can go ahead and find our highest k value, which gave us that accuracy, if you're following. So I'm going to start by firstly deleting this print statement, and then what we want to do is we want to find our optimal k. So we've got this new variable now, and well, let's do this step by step. So I said that we've got this list of kx scores, and we want to find the maximum value. So we can just use this max function, and this is so far just going to return the maximum accuracy. So you know, is it 100%, is it 98%, whatever, it's going to give us the highest value. Now what we actually want though is we want the position of the highest value, right? We don't want the highest value, we want the position of the highest value. So what we're going to do is we're going to say acc scores dot index, and that's going to give us the position. And what position do we want? We want the position of the highest value k. So now we've got a position, So, you know, that might be the 5th element or the 1st element or the 10th element. And what do we actually want though? We want the K. So we need to actually go back to our K values list, and that's actually holding all the values of K from 1 to 49 if you remember. And we're going to use this position to now find the corresponding K value that gave us that accuracy. So I hope you followed along with that. What we're going to do next is we're going to, well, we can actually go ahead and print that now if we want. So let's do that. So we're just going to say our optimal K value is K, and we're just going to use this same format function we've been using this throughout the series, and that should be optimal K. So if we go ahead and execute this now, providing we haven't made any mistakes, then okay, we haven't said import. So let's go back to Emacs. Let's go back to our script. So from matplotlib, so import and let's try that again. Hopefully we haven't made any mistakes. So we have made a mistake. So our mistake is that we accidentally called it ACK_scores and not KX_scores. So let's try that again and execute our script once more. So our optimal K value is 1, which seems a bit weird at first, but we can actually go ahead and confirm this by plotting a graph in matplotlib. So all we're going to have to do is plot. It's like this, I think. And inside here, what do we want along the x axis? Well, it's our K, because we're kind of determining the accuracy from that. And then along the y-axis, we want our ACK_scores. And that's, let's just check everything's correct. That should be KX_scores again. And all we need to do is plt show. If you want, you probably should give an axis. So we'll do plt x label. Then our x is going to be K. And our y label is just going to be ACK. So if we have no mistakes, this should give us a plot now of all the K values we tried for this classifier. And there you go. We can actually see that our best accuracy is in fact, well, it looks to be around 0.83, but no, you can see it's going to be 1 because it's going to be a whole number. And then this will be 3 and so on. And our worst value is actually around 43. But that's it for this video. So we've actually now determined our best K value, which happens to be 1, for this classifier on this training data. So hopefully that was useful, and thank you for watching.